Yeah, you are connected. Are we connected?
Yes, sir.
So, am I audible now? Yeah.
Yes, sir.
Yeah. Can let us get back to the final solution in polar coordinates. We have found the so final solution for in the polar coordinates is u r theta is equal to a naught plus summation n is equal to 1 to infinity r power n an cos n theta plus bn sin n theta. R is equal to 0 case that is included also here. So we have n is equal to 0, yeah, theta. Where is this theta? Sir, you are not audible. Okay. Phone. Am I audible now?
Yes, sir.
Yes, sir.
Okay, thank you. So this is the final solution. Um, as c must be 0, so because of periodicity we will not have this one. A1 is periodicity because the solution should be periodic, and cos of theta plus 2 pi should be when you add theta plus 2 pi, this will not be periodic, so a1 cannot be included. So finally this is the answer. So with this, now go to the problem given. This is the derivation. This is the derivation of solution of Laplace equation in polar coordinates. Solution in polar coordinates for Laplace equation. With this, now we'll go to the actual problem given to us. So what is given, if you read the problem, first A part is solve the Robin problem for the Laplace equation when alpha is greater than 0 is a constant, and when alpha is negative, negative, show that uniqueness fails. So come back to the solution. So here, yeah, we have everything, the solution. So um, first is uh, what is the boundary condition here? What is the boundary at the boundary? What is the solution? So substitute here. Now come to the what is Robin boundary condition? Del u plus alpha times u is equal to beta. What is the boundary? The boundary is a circle. X square plus y square is equal to 1. Or, yeah, it's a circle equation. Circle equation means what? R is equal to 1. R is equal to 1. So substitute in the what is u1 theta? U1 theta is a naught plus R is equal to 1 will be summation a naught plus summation an cos n theta plus bn sine n theta. This is the when r is equal to 1. And also we have normal derivative. Normal derivative is the in the radial direction only. Okay. Outward normal derivative will be the radial direction or negative of the radial direction. So what is u with respect to r? At 1 theta. That means you differentiate this one with respect to r. Then n will come r power n minus 1. When you substitute this one, we will finally get summation n times an cos n theta plus bn sin n theta. N is equal to 1 to infinity. And now club both the things. So beta is equal to r is not there, so beta will be depending on theta. So alpha times a naught plus uh, alpha times this, this is alpha times plus this one, alpha times this one plus this one. So this is equal to alpha a naught plus summation n is equal to 1 to infinity an times alpha plus n cos n theta plus bn times alpha plus n sin n theta. This is the beta, substituting the program. So now we can solve this. What is the unknown here? We have to solve for alpha. These are the solution means these are the unknowns, ans and bns. So we can find them. What is the definite by Fourier series expansion of the function beta theta? We can find a naught, ans and bns. So alpha a naught will be equal to 1 upon pi integral minus pi to pi beta theta d theta, and that implies a naught is equal to 1 by alpha is positive. So this is the thing. So you can find a naught. Then alpha plus n times an is equal to 1 upon pi or 1 upon 2 pi integral minus theta beta theta into cosine n theta d theta. And similarly bn's will be alpha plus n, bn's will be equal to 1 upon 2 pi integral minus 2 pi to pi beta theta into sine n theta d theta. This is by the Fourier series, coefficients of the Fourier series. So we got everything. Now the ans, bns and everything we got. So for alpha positive, we have a unique solution. For alpha positive, we have unique solution. That is what we are asked to prove. Unique solution, because we can find the coefficients uniquely. But now we are asked to see the case where alpha is negative, alpha is minus 1. B part is alpha is minus 1. Okay, when alpha is minus 1, del u del r minus 1, u is equal to 0. So this is the problem, and since a and b are arbitrarily constant, the uniqueness fails. So why the so u r theta alpha is equal to minus 1. Just consider u r theta is equal to, we don't need superimposition, just consider this one factor. b sine theta. To show the uniqueness fails, consider this solution. So what is the boundary? What is u1 theta? U1 theta is a cos theta plus b sine theta, and del u del r at 1 theta is with respect to r, if you differentiate, and there is 1, so a cos theta plus b sine theta. So this what is the a and b are arbitrary constants, so uniqueness. So how does it alpha is considered as Laplacian of u is equal to alpha is -1. Huh. We can take arbitrary. These are arbitrary constants. So one, if you take the different constants, this cannot happen. Laplacian. So how does r is u or theta is this one? So you can how the uniqueness fails is yeah, you can take one solution u1 r theta is equal to cos theta plus sine theta, and u2 r theta is equal to cos theta minus sine theta, because arbitrary, these are arbitrary constants a and b. So I can take a b is equal to 1 and a is equal to 1, b is equal to -1 in this case. This is one solution, this is another solution. Okay, and both so there is no uniqueness. Uniqueness fails because of this negative alpha. Fine. So now we go to the next problem. What is next problem? Again, we are given instead of Laplace equation, we are given Laplacian of u. Problem 3. Okay, we are given problem 3 is, instead of Laplace equation, we are given Laplacian of u is equal to q of x u. Okay, q of x is a non-negative non-negative function. Q of x is greater than or equal to 0. What is that we are asked to do is establish uniqueness theorems for Dirichlet problem as well as Neumann problem. So problem 3. So we are problem. So first Dirichlet problem. Take the Dirichlet problem. U is equal to a function g on the boundary inside omega. First take the Dirichlet problem and prove the uniqueness. Prove the uniqueness. So write the Green's identity here. Green's identity for, suppose there are two solutions and let the difference be w. Then by Green's identity we have this is equal to w Laplacian of u plus grad square by Green's identity. Okay, now u is equal to 0, u is equal to g on the boundary will give us u1 is equal to g, u2 is equal to g, so difference is 0. So w is 0 on the boundary. So the left hand side is 0 is equal to omega w. And what is Laplacian of w? Laplacian of w, Laplacian of u1 is equal to qx this one, and similarly Laplacian of u2 is equal to qx times u2. So difference Laplacian of w is equal to qx times w. So this is W square QX plus grad W square. So this implies that this has to be 0. First case 1 QX is, if it is 0 function, then Laplacian, the QX is 0, then this part is 0, then W is equal to 0, implies W is equal to constant. And by continuity we have we have yeah, why continuity? Because W is equal to 0 on the boundary. W is equal to 0 on the boundary. And here W is equal to constant inside omega. So that constant has to be, because of continuity of W, that constant has to be 0. So W is equal to identically 0. This is uniqueness. And case 2, when Q of suppose it is not identically 0, it is identically 0 case we have considered. That is, there exists a point x naught such that this is not equal to 0. There exists an x naught, or this is strictly positive for some x naught inside the domain. So then what happens? W will be 0 inside. This is strictly positive. So W is equal to 0 inside omega, and then it is implies U is equal to V. Uniqueness has established. Then come to the Neumann problem. That is B part. So again, case Neumann problem will be Laplacian of U is equal to 0, QX times U, and U del U upon del nu is equal to some G or some H. So again, by Green's identity, W nu is equal to, on the boundary, is equal to W Laplacian of W and this thing by Green's identity. So what will be this one? This will be 0. So again we have this is equal to 0, and Laplacian of W will be Q times W. So this will be W square Q. This will be W square Q. And we have again the same argument. Laplacian is 0 on the boundary. Here we have to be little careful. So this grad W is equal to 0 implies W is equal to a constant. So this implies that we don't have W to be 0 here. This is not a Dirichlet boundary condition. This is a Neumann boundary condition. We have del W del nu is equal to 0. Okay, not on the boundary. Not that W is equal to 0 on the boundary. So we have a constant here, implies that U is equal to V plus that constant. The different solutions, they differ by a constant. The two uniqueness phase, they differ by a constant. Uniqueness phase. Now again the case 2 also we can handle, where case 2 has that Q of x naught is not equal to 0. There exists a point where Q of x naught is not equal. Then again Green's identity. Again the same argument. Again here also U and V. Yeah. Again we have. So here what will happen? X not equal to 0. So integral W square Q of x plus grad W square is equal to 0 we have. This implies W is equal to 0, because this is not entirely equal to 0. W is equal to 0 inside omega, and this implies that W is equal to constant. So this is inside somewhere, that constant has to be 0. So here we have uniqueness. Uniqueness is there. So we could do only this much. What are the problems? Other problems we have left. Problem 4 is already done in the lecture. Problem 4, direct verification of to show that these are radial functions. These are harmonic functions. Okay. So problem 4 is done in the class. And problem 5. Problem 5 is the problem. These are the three problem 5 is problem 5 is maximum principle. Maximum, another version of maximum principle. Okay. Problem 5 is maximum principle, and again other things also. Problem 6 and 7 and these are also based on maximum principles. So we'll continue in the next class.
Sir.
Yes.
Sir, what about the second exam?
Once we complete the tutorial sheets, maybe tomorrow I will complete the tutorial sheet. After that we'll have.
Sir, where, like on sir, any date? And sir, will it be a 24-hour exam?
Yes.
Sir, so sir,
Tomorrow is holiday, sir.
yeah, tomorrow is a holiday, sir.
So I think
still we can have a class tomorrow, no problem.
Okay, sir. And sir, so like
if you are not free, you can see the recorded version. I will just, if 1 or 2 comes, it will be good. I can complete the tutorial sheets so that we'll gain some time.
so sir, when
I know that Saturday is also class we have.
Yes.
Tell me please. Yeah.
Sir, so like so sir, then you can conduct an exam on either sir or 1 or 2 May.
1 or 2 means what?
May.
May
Yes.
1st.
Yes, sir, 1st May. Because sir, since Saturday is working and it usually takes more than 24 hours, like you start and then it takes 6 hours to send the papers. So it would be better if you would take both the days to conduct the 24-hour exam.
Both the days means our class days, sir.
No, sir. 1 and 2 May. Those are Saturday and Sunday, and
Okay.
none of them are working.
yes, sir. Generally, you send paper till night, and we did not get the paper whole day.
Correct.
And
Yes,
we had to.
So sir, should I just tell like 1 and 2 May is fine, sir?
No, I'll
Sir,
confirm
on 2
with
we have a quiz.
2 another quiz is there.
Sir, MTL 122.
Yeah. Two we have another quiz. So first let me finish tomorrow the comfortably tutorial sheet 5 also to some extent. Okay. We have done got familiarity with tutorial sheet 4 today to some extent. Rest of the problems maybe you can have a look and we will see what has to be done. Tutorial sheet 5 also let me do to some extent. That is based mainly heat equation. This entirely Laplace equation, that is entirely heat equation. And other things are also there. So unless I do that, we cannot proceed for the exam. Okay, so let me, and that's why I will take survey also, Google Forms survey. What date is preferable? Okay, and 24 hours is the best option because
Yes,
we
sir.
will have anyway open book exam only. 2-3 hours test is 1 hour 2 hour test is of no use. Now we can by heart something, and if that question doesn't come, you all will problem. Why to by heart all these things? Mug
Yes.
up all these things. Yeah.
Yes.
Yeah. It is difficult for me. Actually, open book exam is difficult for me because I cannot find so many questions. Yeah. So let us go. Some learning will happen if it is open book exam. Not just anyway. Grades will not vary much. I will give a liberal grading. So don't worry about grades, but something we will learn while doing the open book exam.
Yes, sir.
It is like a group assignment. Maybe five, 6 people or 10 people will get the same questions and so on.
Okay, sir.
Thank you. Bye.
So, sir, can you like send the mail today or tomorrow, the survey?
Survey now I will send. Yeah.
Thank you, sir.